Now let's expand the transportation problem to include facility location analysis to it. Okay, so here the problem, let's look at an example. So we have a company that produces a component in three different locations: Cincinnati, Salt Lake City, and Pittsburgh, and ships them to warehouses in four different cities: Detroit, Dallas, New York, and Los Angeles. Now, the company is considering building a new plant either in Seattle or in Birmingham. And they have costs of production cost in Seattle and transportation cost out of Seattle into the four warehouses, and same set of costs for Birmingham. So the question is, in which of the two cities we should build our new plant? And then with that new plant, what would be the transportation schedule? Okay. And obviously we want the lowest possible cost. So let's head on over to Excel. So the way we're going to analyze this problem is to set up two different problems. Okay. So we have the existing three cities and four warehouses, and we'll add Seattle to the mix. And then we will take, instead of Seattle, we'll put Birmingham and solve the problem. So between the two problems, the one that gives you lower cost will be the one that we will select. Okay. So let's enter the information, the input information given. Okay, so these are the costs of transportation from each of the existing plants to the four warehouses and the one that is proposed, one of the two that is proposed in Seattle. So let's format this. Okay, and format it as input. All right. Then we have production cost in each of these plants. That's given, okay, as this. Once again, let's format it. And this is unit production cost, and that's input as well. Okay, let's complete the formatting. Okay, so now we will proceed like what we did in the previous exam transportation problem. So we're going to look at transportations here. So that will be, those are the changing cells. Okay, and the supplies are given. Okay, so the problem states what the supplies are. So here these are the monthly supplies. Okay, and these are the monthly demands. Okay. And these are the costs. So, all right. Okay, so these are input. So let's okay. So the new proposed plant capacity is 11,000, either at Seattle or in Birmingham. And the demands are also given for the warehouses. Okay, so we saw that over here. The demands are these. Okay. All right. Now, what is shipped is sum of that, and that has to be less than or equal to the supply. And what is received is the sum like that, and that should be equal to the demand. Okay, let's align it properly. Okay. So now in addition to shipping cost, we have to include the production cost as well. So from each of the plants, these are the total amounts that will get shipped. So if you have a sum product of the unit cost and what gets shipped, that will give us the production cost. So unit cost of production and what gets shipped out. So that will be our production cost, and shipping cost will be sum product of these with these. Well, let's put the cost first. It doesn't matter which order we enter the ranges. All right, so and then the total cost is the sum of these two. So let's format this. Okay, now that is our objective function. All right, so now we have set up the problem. Now we can run the solver now. So that is our objective function, and we want to minimize that. And this is the changing cell, and add what gets shipped out must be less than or equal to supply, and what gets received must be equal to the demand. Okay, so now one thing we should have done is to sum the demand and supply and see whether it will be feasible, and it is feasible. But anyway, let's do it. 22, 32, 37, 46,000 is the demand, and here 21, 31, 35, and 46. So that's good. Now make sure non-negative and simplex LP and solve, and we have a solution for Seattle. Okay, so now we have to repeat this, but replace Seattle with Birmingham. Okay, so we're going to now repeat this problem. So what I'm going to do is to just make a copy of this sheet, so we can only, then we need to change only one thing and run the solver again. So let's so right click the sheet, move or copy, and create copy, and let's select that and move it here. Okay, so I'm going to get rid of this sheet and use this one. So let's get rid of that, delete. Okay, and then let's name this sheet 3. Okay, so now we need to enter the information for Birmingham. So Birmingham transportation costs are 35, 30, 41, and 50, and production cost is 49. Okay, and the rest remains exactly the same. So go to solver, and we don't have to change anything here. They're all already set up correctly. Click OK, and we have a cost of, okay, let's make sure that it's okay. So we start from a fresh changing cells is all 0. Now solve, and we have a solution. So now we need to compare between Seattle, where the cost is 3,704,000, and cost, if you locate the new facility in Birmingham, be 3,741,000. So the choice will be Seattle.